The next section here is Section 9, Multiple Contingencies. There's not a lot more that goes into defining multiple contingencies than single contingencies. It just mostly it changes how you run a transient stability run and then how you view the results. So instead of, we have different options for the time values and different options for the data storage in terms of when you have multiple contingencies as opposed to just one contingency defined. Or I shouldn't say that. You can define multiple contingencies all the time but only run them singly, or define multiple contingencies and run them as multiples. Things that change: the simulation page changes, the plots and results change. Tom has done quite a bit of going through the state's manual control options so you can step through a simulation. That goes away when you decide you want to run with multiple contingencies, and the rest of the things change very slightly. One thing to note here, the validation. The validation doesn't change, even though we've had some discussion on maybe we should change the validation slightly when we go into the multiple contingency option, because remember when Tom talked about this yesterday, there is that option when you're checking your time constants to relate those to the time step. They have to be a certain multiple of the time step. When you do run multiple contingencies, you can change the time step for each contingency, so that might change your validation slightly. But the way we do things right now, we validate once, and that applies throughout. So hopefully you won't run into any problems because of that. Most of the time I would think you would run your multiple contingencies all with the same time step anyway. So let's go into Simulator and just take a look at how things change. The case we want to start with here is something called the TS9-bus CTG EX case, so the contingency example case. Again, that should be in your training cases folder, in the transient stability folder. It's the TS9-bus CTG EX.pwb file. So go ahead and open that. And then we do the multiple contingencies from the same dialog we've been using all along. So open the transient stability dialog. And you'll see an option here. Let me shrink this. If you look down in the bottom left-hand corner of the transient stability dialog, there's an option called Process Contingencies, and we've had this set for the most part at one contingency at a time. Now we're going to change this to multiple contingencies. So if you click that, you'll notice that your simulation page here changes. So if you no longer see the start and the stop time and the time step, but the top of the simulation page switches to a transient contingencies table, which looks somewhat similar to the power flow contingency table if you're used to looking at that. The start and the end times and the time step are now as defined as part of the contingency rather than on the dialog itself. The lower portion of the simulation dialog remains the same. You still see in the lower left the transient contingency elements, and then we'll talk about the limit monitors in the next section, which deals with the lower right section of the simulation page. So let's go ahead and add another contingency to this case just so we can see what that means as far as multiple contingencies go. So right now we've got a fault at bus 5. So we want to add a contingency for, let's see, opening a load, I guess. So to add a new contingency, if you go up into the top section, the Transient Contingencies table, right-click and choose Insert, then automatically it has created a new contingency called My Contingency 1. It'll just keep incrementing the number of contingency. But if you click between these two, you'll see that My Contingency 1 has no elements associated with it. And if at any point in time you want to change these names, all you have to do is just type directly in this field, and you can change that. So if you wanted it to be something else like mine, you can just type in there for something more descriptive to what it is. So then we need to add some elements to this. So to do that, we need to go down to the Transient Contingency Element section, and like we did yesterday, either click on the Insert button or right-click and choose Insert. And then the event that we want to add is on slide 7. So we want to open a load and then close it. So we need to add 2 events. The first one will set the object type to load. The description type is open. The load that we actually want to open is load 8, so we select that from the chooser. We want to open the load at 1 second, so the default of 1 second for the time is correct, and there are no other options that we need to change, so we can just hit OK, and then you should see an element show up for load at bus 8. And now we want to add a second element that will close that load. So again, right-click or click the Insert button, and again, change the object type to load. Pick load 8 in the chooser. This time the description type is close, and then for the time we want to change the time to 1.5 seconds. And then once that's all set, hit OK, and then we should see our second action show up with our contingency. And then if we switch back and forth up in the upper table here with the contingency element, or the contingency names, you'll see that the lower section changes to show you what elements are with each contingency. Okay, so the plotting changes if we go to the plots definition, or the plot designer. Now you'll see up in the top section of the plot designer, there's a checkbox that says plot multiple contingencies, or choose contingencies to plot. So if you have the plot multiple contingencies button unchecked, then the only contingency that will be plotted is the one that's showing in the drop down. So if you want to plot multiple contingencies, you check the box, then the drop down option gets grayed out, and then the choose contingencies to plot table becomes relevant. So if you are running a case with a lot of contingencies in it, it's probably not going to make sense to plot every contingency, so every bus frequency for every bus under every contingency on the same plot. If you wanted to do that, you could, but it's probably not going to make much sense. So if you want to plot multiple contingencies and compare the results of one to another, you want to make use of this, the choosing the contingencies to plot table. Change the show field to no for all the ones you want to exclude, to yes for the ones you want to include. Just make sure that you're not putting too much information on a single plot. And then with each contingency, to distinguish between the contingencies on the same plot, you can define a color and a line style, which is the plot dashed, the thickness, and the plot symbol, to further distinguish between those. If you leave everything at default, Simulator just picks something for you. So for now, I'm going to leave those at default, this is a small case. We can plot both of these together. So I'll just leave the defaults there. But so let's go ahead and run this for now and see what we get. So if we go back to the simulation page, the button is moved slightly. It's over here on the tab rather than underneath the simulation status. So if we click the button, it goes through rather quickly. And we didn't have any plots to define. We did have plots. Where did my plots go? Not sure why my plots didn't show up automatically. But if yours didn't, you can come to the plot designer page and then click generate selected plots. So now what you'll see, legends under the plots will reflect which contingency is being shown. It looks like here the defaults, we don't have any symbols or anything, so it's kind of hard to distinguish between the different contingencies and the different values. By default, simulator is going to pick the same color for the same fields. So if we go back to the choose contingencies to plot option, and for one contingency, for my contingency, I'm going to change the plot symbol to be, let's say, a diamond, and maybe change the plot dashed to be maybe a dash, and then close that, and then regenerate the plots. So now I'm seeing my the lines are dashed now, so you can tell the dashed ones are my contingency, and the solid lines are the contingency called mine. If you don't want to do the multiples, then uncheck the plot multiple contingencies, and then switch which contingency you want to plot. And then when you select the generate selected plots, it only shows that contingency. It declutters things a little bit.
So that choose contingencies to plot, and when selected plot color, you change it.
Yes.
I don't see selections if you go back to default.
Oh, I think if to change the plot color back to default, if you just type default in there. Yes, I think that'll work. Let's see. Yes, you can. Yeah, you can just type over the color, type in default. I wonder if did the colors change like they should? Okay, so the colors are working. It just seems that the symbols aren't working. Okay. So the next thing that changes when you have multiple contingencies is the results from RAM. So if we go to the results from RAM and look at time values, you'll see this kind of warning yellow note here at the top that you can only view one contingency at a time in the time results. So you make use of the drop down at the top, the for contingency drop down. If you toggle between that, you should see the values change as you change between contingencies. We decided it just was too much to try to show multiple contingencies on all the time values, and it really wasn't that meaningful. So you really have no choice there. If you want to show them all together, you're going to have to, do something yourself in Excel to put the values side by side. The other thing that changes slightly but not drastically, when you're saving results to hard drive, so if we go to the results storage, save to hard drive options, you don't really change anything here as far as your setup goes. it's more a matter of just to be aware of how the results are stored. There is a note here. Remember, when you save to hard drive, you define a location where your TSR files are located. The naming convention that we follow is that the TSR files will be named based on the contingency name. So again, if you are trying to run multiple studies using the same set of contingencies, create different directories, otherwise everything is going to overwrite. We decided, because of the way we load information in, we've had people ask before if they could append something on the file names, but then because of the way we recognize the TSR files as far as bringing data in and plotting, we've kept it to where it's always going to be the contingency name. So you really have no choice as far as what the naming convention goes. The last thing here that you can do with multiple contingencies, we haven't really talked about this. We've talked about manually creating contingencies, but there's also an auto insert button here at the bottom of the transient stability dialog. And I think there's also an option, maybe it's not. I guess it's only at the bottom. The button at the bottom of the dialog, auto insert, you can auto insert transient contingencies somewhat in the same manner you can do with power flow contingencies, with a few variations here in that you have to define a time. So we allow you to auto-generate single transmission line or transformer, gen or bus types of contingencies. Then you define the time that each event's going to start, how long it's going to last, and if it's a line type of fault, the location of where that fault's going to occur. So in a small case like this, we can just go ahead and try this out. So I'm going to stick with the defaults. Single transmission line, the event time is 1, the duration is 0.083 seconds, and just hit do insert, and what we'll see what we get if there is a little bar that will move change the size of the top part of the dialog in the bottom. So if you hover over that and you get those little up down arrows, you can move it. So what it did is it created faults at the near end and the far end of each transmission line, and for each of the faults, it inserted an event default, do a 3-phase solid fault on the branch, and then it clears the fault by opening both the near end and the far end of the branch, which is what we discussed yesterday, which is what you expected as far as fault clearing goes. So that's an option if you just want to quickly do some analysis on your case and not go through and have to manually create all these different contingencies. And then beyond that, that's pretty much all that goes into the multiple contingencies. Everything else applies. You know, the analysis is going to be the same. It's just we process each contingency one at a time until they're all completed. There are options here. Skip. So if you have a bunch of the skip field, if you have a bunch of contingencies defined, but you don't necessarily want to run all of them, you can set the skip field to yes and skip those. Again, that's very similar to what the power flow does, the power flow contingency does. And then there's some options over here for some summary information. I assume maybe Gordon will talk about some of that when he goes through his example, because Gordon has had opinions in the past on things that needed to be added with our summary tables here. So
when you're talking about multiple contingencies in this, these are single contingencies, not simultaneous contingencies.
Correct. They are single. They're applied sequentially. So we apply one, then we go back to our starting case, apply another. They're not like cascading or sequential or anything like that.
What do you mean by sequential? Because each contingency can have multiple. multiple operations in it.
Right, so the fault and the load, you can have multiple operations. Right, so the fault and the load, you can have multiple operations. Right, so the fault and the load, you can have multiple operations. Right, so the fault and the load, you can have multiple operations. Right, so the fault and the load, you can have multiple operations. Right, so the fault and the load, you can have multiple operations. Right, so the fault and the load, you can have multiple operations. Right, so the fault and the load, you can have multiple operations. Right, so the fault and the load, you can have multiple operations. Right, so the fault and the load, you can have multiple operations. Right, so the fault and the load, you can have multiple operations. Right, so the fault and the load, you can have multiple operations. Right, so the fault and the load, you can have multiple operations. Right, so the fault and the load, you can have multiple operations. Right, so the fault and the load, you can have multiple operations. Right, so the fault and the load, you can have multiple operations. Right, so the fault and the load, you can occur at the same time. Let's say we have off the bus and we lose the load at the same time. So what's the effect on the system?
Yeah, I mean, you
both
could.
contingencies occur.
Yeah, in a contingency definition, what we call a contingency can have multiple events that can occur at different times or simultaneously. We call that a contingency. I mean, the full contingency. It's got contingency elements that are open the load, fault the bus, trip the line, blah, 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 whatever you want. You can have as many events in that contingency as you want. Then the multiple contingencies are just processing them sequentially.
Yeah, when we were looking at the two plots, though, and seeing what was going on with the load and seeing what was going on with the buses, those are two separate events, not...
Yeah, they're separate. They're separate contingencies.
Right.
So the user doesn't have to reinitialize. There's no definition for restoring the initial state after each contingency. When you do the fault, clear the fault, before the next contingency, you're running the initial state. There's nothing in there to define to say restore initial state.
Right. The user does not have to restore an initial state. The software handles that. So once you start the transient run, that's the initial state, and then it returns back to that in between each individual contingency. So yeah, you don't have to worry about that.
So the design of it is, if you just think of the powerful contingency analysis, and the attempt is to make it the same thought process.
Yeah, that's exactly right. I mean, that's the design, and it comes from the fact that before we start the transient run, we have stored everything. So we kind of put it over here. While we're running the stability runs, as we've shown you, we have the ability to take data from the stability run and put it back in our PowerFlow model. Then when you restore the reference, which takes place automatically during the multiple contingency runs, we start afresh. So everyone's separate.
So just as an extension of that, if you have a three-terminal line, is that defined in here, or is that not defined in here?
You have to define.
Okay.
So, like the auto insert doesn't know.
Okay.
So it seems like contingency blocks can't be used.
Right. There are no contingency blocks with the transient contingencies. It's completely separate. The blocks are only used with the PowerFlow. So if you wanted something repeated in multiple contingencies, you'll have to manually put those actions in.
But this, I will say, this is the sort of thing where we're looking for what do you guys want? And so this is an evolving product. And if people want to run a whole bunch of things where you have the ability to do a contingency block, like on the PowerFlow side, we can probably get that set up.
What types of things are you thinking you would put in a block?
I don't. One side is like for the COI RAS, we have multiple double contingency line outages that trip gen drop. So there's like 5. How many combinations are there in the COI RAS? Maybe 20 different line combinations that will trigger gen drop. Because would we want to do that? For multiple generations throughout the web.
Yeah, RAS on the transient side is still kind of a hazy sort of thing. It's not clear to us exactly what people want to do with that, if it needs to resemble RAS from the PowerFlow or if it needs to be individual RAS models. So that's, something to talk through and figure out what is actually needed. We brought a little bit of the transient into the PowerFlow side of things with some of the transient models being available during a PowerFlow contingency, and then we've actually have time fields now that aren't necessarily the same as time fields in transient, but do imply an order in which events occur during the PowerFlow. But that's as close as we've got. We've stopped short of trying to do, the RAS and the transient like we've done the PowerFlow, just because we're not sure that that's the best way to do things.
And Jamie's been very involved in this more than me. Have you been involved?
Yeah.
But we never have any direction yet.
Well, right, yeah, I mean, we need you guys need to work with the vendors, what do you want, and then it can get implemented. But yeah, it's not simple.